Okay, welcome back. So today we are going to visit using our calculator. Uh, this is a skill that everyone would like to have. A little note from the author, I actually took this from the textbook. When evaluating trigonometric functions of angles given in degrees, make sure that your calculator mode is in degrees. Get in the habit of always starting work by entering sine of 90. If the displayed answer is 1, sine of 90 degrees is 1, then the calculator is set for degree measure. So let's just make sure we're all on the same page. So I pull up the calculator, and for me, I go to mode, the mode button here. So say I'm on my blank page, I hit mode. See, I'm currently in radians. So I go down, slide over to degrees, make sure I'm in degrees. Okay? Now, let's see what's on the next part. Okay, let's practice using our calculators together to see this happen in real time. So you see I have a screenshot here, but let's practice actually typing this. So sine of 49 degrees and 12 minutes. Sine 49. If you go under, see how it says angle in yellow? Second angle. See, there's my degrees, minutes, my radians. So 49 degrees. I'm going to go back in, and what was it, 12 minutes? Oops, let's type 12. And go back in, see, angle's written in yellow, so I'm going to hit second matrix to get angle. Down to minutes. Excuse my nasal voice today. I have a little bit of a cold, but 49 degrees and 12 minutes. Hit enter. And we should see the same thing that is on that screenshot there, 0.75699. Now let's practice the next one. So now let's practice the next one, which is secant of 97.977. Notice that calculators do not have a button for secant. So secant is the reciprocal of cosine. So instead, you'll just find cosine of that angle and then just do 1 over that. So I would hit cosine of 97.977. So style-wise, that's what I would do. I would hit that. And then I will get the reciprocal of that. So I would hit 1 divided by second answer. Second, and answer in yellow there, second answer. See? Negative 7.2. So the secant of 97.9 degrees is about negative 7.2. Okay? Now let's try the next one. Approximate the value of each expression. So notice that it says to find 1 over the cotangent of something. But cotangent of 51 degrees is, cotangent is the reciprocal of tangent. So if I found, 1 over tangent of 51 degrees, but then if you think about that as a complex fraction, and in fact I'll even write that here, 1 over tangent of 51, 0.4283 degrees. That's the same thing as saying tangent of 50, so that's why we end up just typing tangent. 1 over something is just going to send you right back to tangent of 51 degrees. So just know that you're oftentimes utilizing these reciprocal identities that we had talked about before. That tangent is the reciprocal of cotangent and vice versa, and cotangent is the reciprocal of tangent. So with that, we see the screenshot there, but we'll just practice it together. We're just going to hit tangent 51.4, and I don't have to type by the way, I don't have to type the degree symbol if the calculator's set in degrees, which it is. So 1.25, we got that one. Okay, let's try the next one. It says to find the value of sine of negative 246 degrees. Now let's just type that in as is. Sine of negative 246. So it spits out the 0.9135, but that's great, but I just wanted to think about, why that might be. Why is sine of the negative angle, why does it come to be positive? So we just really want to think about what quadrant it lands in. So let's just take a moment to visualize that in our head. Here I am, I'm rotating negative 180. Now if I went all the way to here, I'd be, at negative 270. So I know, I'll do this in another color. I know that I don't have to go that far. I only go to negative 246. So that negative 246 degree rotation, just think about it. I mean, I'm going to land in quadrant 2. So think about sine. Always be thinking about the signs. So sine, is it positive in that quadrant? Sure it is. So that's why that's coming to be positive. So in other words, we don't always want to just believe whatever the calculator says. We should always think about drawing it as well. Okay, and then let's take another look. Use a calculator to find an angle in the interval from 0 to 90 that satisfies each condition. So this is a good skill to have. We're going to be going to it deeply by hand in a future chapter, but if I say that sine of theta is equal to 0.967 approximately, how do you find theta? Well, to find theta, it's like saying sine of what angle is equal to 0.967? Well, to find theta, I will just have to hit inverse sine. So to undo sine, you use its inverse function, which is inverse sine. So to find theta, I'll just hit inverse sine of that value that was given, etc. Okay? And you can see, that's what we do right here, but let's practice with that button. So to find a particular angle, you'll be using the inverse key. So I'm going to hit, let me go back to the blank screen. So you see inverse sine is in yellow above sine, so I'm going to hit second. See the little -1? That doesn't mean the reciprocal of sine. Big note to self. It does not mean reciprocal. It means inverse sine. So inverse sine of 0.96770915. See, you're looking at about a 75-degree angle, and you see that there on the answer key, 75.4. All right? Now, let's do a little translation here on this one. Secant of theta is equal to this. Now, I'd love to be able to hit inverse secant, but there is no inverse secant button. So secant is really the reciprocal of cosine, right? So I'm going to hit inverse cosine, but I can't hit inverse cosine of that value. I have to hit inverse cosine of the reciprocal of that value. So that's a little bit tricky there. So here's what I would do. I would write a recipe here. Secant is the reciprocal of cos. And I would love to be able to hit inverse secant, but instead I'm going to have to hit inverse cos. But instead of using the current argument, I'll use the reciprocal of that argument. So that means I'm going to have to hit inverse cos of the reciprocal of that number that was given, that 1.054, etc. So let's just practice thinking through that process again. I like to think of it as, look, you wish there was an inverse secant button, and there isn't. So use cosine, but you'll have to use the reciprocal of the argument. Okay, so we'll hit inverse cosine of the reciprocal of that which was given. So 1.0545829. And we get about 18.5. Yeah, so that's a little tricky. You definitely want to practice that, using those reciprocal identities. Caution, as you see, reciprocal and inverse do not mean the same thing, and you use the inverse key when you are trying to find an angle that meets a certain criteria. Okay. Couldn't live without a lovely word problem at the end of the section. So we are not in a physics class, but it definitely is my goal to start exposing you to some physics problems, and we will throughout the year, throughout the term. Finding grade resistance. So when an automobile, this will be our last problem for today, when an automobile travels uphill or downhill on a highway, it experiences a force due to gravity. This force, in pounds, is the grade resistance, and it's modeled by the equation F equals W sine theta, as we see here, where theta is the grade and W is the weight of the automobile. If the automobile goes uphill, theta is going to be positive. If the automobile goes downhill, theta is going to be negative. So theta's, notice it's rotating from the horizontal there. Well, we'll be dealing a lot with that later in the term in terms of us having to think about drawing these things on our own. But for now, it's given to you. We just want to practice the plug and chug of it all and seeing if our answer makes sense, because this section is really just about using your calculator. So, for instance, calculate F to the nearest 10 pounds for a 2,500 pound car traveling an uphill grade with theta equal 2.5. So we're literally going to plug into this equation here. 2,500, plug in for weight, sine of theta, sine of 2.5. Now let's type that in. So 2,500 times sine of 2.5. Now look at the answer though, 109 and some change. But it said to round to the nearest 10 pounds, to the nearest 10 pounds, not to the nearest pound. So you have to think about, is 109, is it closer to 100 pounds or is it closer to 110 pounds? And that has to do with significant figures and significant digits in science, sig figs. Well, I'm not going to go deeply into a conversation of sig figs. We'll just follow the author's lead there. So notice that 109 got rounded to 110 because rounded to the nearest 10 pounds. Okay? Calculate F to the nearest 10 pounds for a 5,000 pound truck traveling at a downhill grade of theta equals negative 6.1. Well, all right, we'll plug 5,000 in for, and I should probably highlight this because I'm talking about it but not saying it. We'll plug 5,000 in for the weight. We'll plug the negative 6.1 in for our angle. And let's practice crunching this out. But notice again, it says round to the nearest 10 pounds. All right, so I'm going to actually hit sine of negative 6.1. Get that answer, and then I'm going to multiply that by the 5,000 weight. So I get this negative 530 pounds, and you say, why is the force negative? So that actually makes sense then, that the force is negative because it's moving downhill. So those are just things that you can think about before we head deeply into like a physics chapter. So you're associating, okay, downhill, negative force. Whereas this one was uphill, positive force. And something to chew on. Take a look at this last one. Calculate F for theta equals 0 and explain why this makes sense intuitively. Well, let's just do that together. So F equals W sine theta, right? But the thing is, if theta equals 0, well, what is sine of 0? 0. So it doesn't matter what the weight of that automobile is or that item is, force is going to be 0. And if you think about it, it makes sense because if theta is 0, that means you're not on an incline or a decline. So gravity is not pulling it uphill or downhill, right? So in other words, the force is 0 because we're not going downhill or uphill. We're at a flat, there's no grade, there's no gradient. So that does make an intuitive sense then. All right, hope that helps, and that's all for our calculator demo for today. Good luck.